Great Lakes.
The Great Lakes.
Great Lake.
Great Lakes.
A blast of Arctic air is causing a deep freeze on the Great Lakes tonight.
Stretching across the heart of North America, a chain of massive inland seas gleams under the sweep of clouds, the Great Lakes. From the marshy reeds of Lake Erie's southern shores to the remote stillness of Superior.
The Great Lakes Shipwreck Historical Society has announced the discovery of a 132-year-old shipwreck in Lake Superior.
These waters have always been more than geography. For the towns and cities pressed to their edges, the lakes are cradle and marketplace, barrier and passage. They thunder in winter, whisper in the heat of July, mirror the endless sky. Yet even such apparent permanence comes with secrets. Today, beneath those cold, shimmering mirrors, so familiar and so vast, a new story is stirring. In laboratories across the Midwest and Ontario, and from observatories high above, researchers have uncovered signs of profound, invisible change. Heat waves roil the lake surfaces with growing frequency. Cold spells snap the seasons. But it is underground, beneath the rocky skeleton of the continent itself, where the greatest questions now lurk. Armed with satellite constellations and advanced geophysical tools, scientists are unraveling the foundation of North America, finding places where, astonishingly, the Earth seems to be changing far below. Unusual formations, strange blobs of rock, are detaching from the base of the crust, sinking slowly downward. New research, both bold and careful, is challenging decades-old faith in the land's stability. Does the real secret of the Great Lakes lie not in their blue surfaces, but in what waits below? Ancient wounds, unfinished stories, and processes so peculiar that even geologists confess their alarm. What have we truly been living above all these years? Unmasking the ordinary, the Great Lakes through time. Long before steamboats traced their wakes through Superior's depths, or Erie froze into labyrinths of ice, the Great Lakes were already layered into North America's story. For centuries, geologists traced their origins to immense glaciers that scraped and gouged the land, carving deep basins and leaving behind a legacy of fresh water. This narrative of ice as an ancient sculptor became textbook dogma, a saga of gradual shaping, retreat, and fill. But in recent years, as satellites peered down and sensors drilled deeper, that reassuring narrative has become more complex. The first hints emerged not from cataclysm, but from anomalies, unexplained heat beneath the crust, seismic waves traveling faster than expected. Landsat 7, the USGS's ever-watchful satellite, has been key, allowing scientists to trace subtle surface changes with greater fidelity than ever before. What seemed familiar acquired layers of strangeness. From shoreline to shore, researchers observed heat waves and cold snaps with increasing precision, exposing a restless pulse beneath the lakes, a rhythm that outpaces memory. Old stories of gentle thaws and routine freezes have given way to data-driven alarm. Weather in this region is no longer just changeable, but increasingly extreme. And then came the discoveries underground. Computer models, originally designed for tracking ocean currents, were adapted to the lakes, allowing researchers to peer into the secret world beneath them. What they found began to unsettle even experts in slow geologic timescales, a tempo measured in millions of years, but now showing dramatic changes within a single human lifetime. Was the landscape always so fragile? Or are we only now learning to hear its buried anxieties? Earth in melt, the dripping continent. The story of what lies under the Great Lakes is, at its essence, the story of how continents themselves can transform, slowly, inexorably, in ways that defy our sense of permanence. In 2025, scientists confirmed a finding that had troubled seismic researchers for years. The underside of North America is not simply solid stone, but includes regions where the lower crust is literally dripping away. Imagine, if you can, a block of ancient rock, heavy, stable, supporting everything above. Now picture that block, instead of remaining a quiet foundation, starting to sag and separate, with immense, bulbous blobs breaking off and pulled by gravity, slowly descending toward Earth's mantle. This is not a sudden catastrophe, but a geologic process spanning eons, one now captured by satellites and computer models refined for studying both oceans and Earth. At nearly 3,000 kilometers below the continent, researchers have found seismic evidence that the very composition of the Earth is shifting. In certain areas, especially deep beneath the Great Lakes Basin, seismic waves race ahead at unexpected speeds, an uncanny sign that something fundamental is happening in the lower crust and mantle. These drips, as scientists call them, are irregular, not uniform or widespread. Some seem clustered beneath the Great Lakes. The implications for those who interpret Earth's unseen interior are profound. In a region as ancient and apparently settled as the lakes, why does the Earth appear to be thinning from beneath? What energy or history created these drips? And what does it mean for the land above? Are we, perched at these lakes' edges, living atop a world that is quietly, inexorably letting go below? Signals in the waves, the technology uncovering change. Scientific progress often emerges from mismatches where observation refuses to fit expectation. In the story of the Great Lakes, the gap became a chasm. Equipment designed for the world's most demanding ocean research, radar altimeters, interferometric sensors, and seismic arrays, has been repurposed and deployed to the Great Lakes region. Satellites, including the notable Landsat-7, now monitor the land and water with unwavering regularity. Through this technological arsenal, the lake's surface has revealed itself as a patchwork of temperature extremes. Heat waves and cold spells swing through with greater ferocity than even seasoned locals recall. Research out of the University of Michigan documents not just fluctuations, but step changes. Weather, once only variable, now shows a pattern of deeper extremes. Yet as instruments map the water and land, others look deeper into the earth. Subtle seismic signals, mapped by networks of instruments, have sketched out subterranean features, hollows and drips, where crust and mantle are most in flux. Rather than uniform stone, scientists see a foundation punctuated by pockets, where the Earth's lower layers thin out and shift. Models, originally devised for oceans, now simulate flows of semi-molten rock under the continent. When fed with the peculiar seismic data, strange speeds, unexpected lens-shaped zone, these models reveal a portrait of subsurface instability. Beneath the Great Lakes, large swathes of the continental understructure appear less steady than once assumed, not on the verge of collapsing tomorrow, but on a timescale significant enough that scientists can't ignore the warning. What is the true significance of such slow changes? What might they mean for towns, cities, and the entire region built on the assumption of unyielding ground? The Great Lakes, reimagined, how hotspots rewrite history. Change in the Earth is recorded both in what occurs and in the stories we tell about the past. Recent research from 2025, spanning institutions in the US and Canada, is upending the classic tale of how the Great Lakes were born. For decades, the textbook explanation held that glaciers carved the basins, monolithic sheets of ice scraping away rock, filling depressions with meltwater. But new studies suggest a deeper origin, the imprint of an ancient hotspot, a place where upwellings of mantle heat irreparably weakened the crust, leaving wounds long before or after the glaciers arrived. This hotspot, marked by pulses of superheated rock tens of millions of years ago, may have fractured the crust beneath the lakes, rendering it susceptible to collapse and deep enough to accommodate vast quantities of fresh water. The lakes, then, would be more than relics of the last ice age. They are the product of deep earth energy as well as glacial force. The data show patterns of thinning, hollows, and ghostly signatures that do not wholly align with an ice-only theory. When placed alongside the unsettling tale of modern-day crustal drips, A new image emerges, the Great Lakes region as unstable ground, always shifting, a dynamic landscape of hidden vulnerability. The lakes may owe their existence not only to the scouring of ice, but also to ancient surges of heat and weakened crust. What else, then, sleeps in those depths? What stories, dangers, or histories only just now coming to light? Reluctant witness, human life on an unquiet land. It is easy to forget, amid ferry rides and summer cabins, that every settlement around these lakes rests on an assumption of geologic stability. But the new signals, multiplying beneath the lakes, challenge that comfort. Modern civilization has rooted itself on the lakeshore. Detroit's towers at the river's mouth, Duluth's harbors, Sault Ste. Marie's essential canals. But what does it mean if, however gradually, the ground begins to change? Scientists scrutinizing decades of satellite and seismic data caution that even changes measured in millimeters, tilts unseen by the naked eye, microfractures invisible to sensors, could build up to major transformations. Over centuries, or perhaps in sharper interval, the foundation on which cities stand could subtly shift. Already, changes in weather seem to echo the uncertainty below. University of Michigan research has shown that both heat waves and cold extremes are occurring more frequently and with greater intensity. This adds insecurity to the region's future, altering prospects for forests, crops, and even drinking water. Is this only the churn of a warming planet, or does it signal something older and deeper, a pattern rising upward from the disturbances below? Residents ask, sometimes uneasily, whether the lakes they knew are changing more rapidly than before. Why do shorelines erode with such force? Why do some bays warm years ahead of projections, while others freeze as never before? Where land once seemed everlasting, an undercurrent of nervousness now exists about what the future may yet reveal. Will the communities that encircle these lakes endure untroubled, or are they living above, and perhaps within, the slow drama of a continent's transformation? Hydrogen from the depths, promise and peril. Amid warning signs and sobering discoveries, one potential benefit and risk emerges. In 2025, the U.S. Geological Survey published a landmark study mapping the potential for geologic hydrogen in the Earth, including regions around the Great Lakes. Hydrogen, the cleanest of fuels, might be produced deep in the Earth, offering a possible transition away from fossil fuels. But tapping such resources means reaching into the most enigmatic and unstable layers of the crust. The very drips and voids that unsettle geologists also create microenvironments for hydrogen generation and accumulation. Extraction would require drilling through fractured, unpredictable rock, presenting geotechnical challenges significantly beyond those of standard oil and gas. Researchers warn the instability of the deep crust could make any exploitation risky. Disturbances might trigger new subsidence or unpredictable changes, with implications that reach beyond energy. Geologic hydrogen offers a tantalizing future, but also embodies the tension of humanity's search for solutions, investigating into domains barely understood. Is it prudent to harvest deep hydrogen from complex, potentially unstable geology, or does this ambition risk inviting unknown consequences? As with any hidden treasure beneath our feet, the unknown shades both the promise and the peril. Ancient clues, rewriting the record of the lakes. Discovery is a perpetual reimagining, not just of the future, but of the past. The evolving theory that a hotspot was essential in forming the Great Lakes disrupts the tidy chronology of geology. Beneath each shoreline, every ridge and promontory may lie the mark of titanic struggle, fire battling ice, collapse alternating with renewal. Samples, extracted from deep beneath the lakes, show surprising irregularities. Valleys layered within valleys, unexpected mineral deposits, collapsed corridors, and evidence of high-temperature processes amid glacial silt. Such complexities don't fit cleanly with an ice-only story, but suggest a multi-episode, sometimes violent history still reflected in the present landscape. Seismic signals, undetectable to people, but clear on scientific instruments, occasionally ripple up through the bedrock, Warning from the depths, the politics of attention. Awareness, in science as in public policy, is never equally distributed or lasting. As discoveries beneath the Great Lakes have multiplied, so too have calls from scientists throughout the Midwest and Ontario for vigilance and sustained investment in research. These calls warn that without adequate monitoring and analysis, dangerous trends might remain undetected until it's too late to act. Some public voices urge calm, pointing to the lake's rich, enduring history, referencing the disasters that never arrived. Others, reading the record in stone and water, call for preparation, more advanced monitoring, stronger networks of sensors, and expanded research into the lake's evolving risks. Funding, though, has not always kept pace with needs. The sheer scale of the Great Lakes and the difficulty of peering through kilometers of water, sediment, and stone stretch the limits of scientific technology. Satellites, seismic arrays, and sophisticated models all work in concert, yet even together, they struggle to match the tempo of change, which mixes the rush of weather with the slow crawl of the deep earth. When the next warning comes, a subtle shift, a tremor, an unexplained spike in water temperature, will it be heard? Or will chronic distraction, the rituals of storms and floods, obscure our view of what matters underground? The new calendar. What if the ground fails? In the end, all scientific inquiry returns to one central anxiety. What if the ground gives way? Not suddenly, perhaps, but in the quiet, corrosive manner suggested by recent models, a hollowing out, a breakdown of structure, an erosion of the foundations on which land and life both rest. The consequences are difficult to predict, but the precursors are increasingly visible. Rising lake levels, not entirely explained by recent rain or runoff, may sometimes reflect subtle land subsidence as well. Some stretches of coast erode at rates previously unseen. Infrastructure, pipelines, bridges, tunnels could someday be betrayed by land no longer as stable as engineers assumed. Ecosystems, balanced on the edge of change, might be thrown into confusion as temperatures swing, banks erode, and aquatic habitats shift. In some scenarios, even the very boundaries of the lakes might subtly alter. Islands could sink, or new shallow areas may appear, reshaping the region's ecology and human settlement in ways no one had foreseen. A landscape forever unsettled. And so the story returns, as all stories do, to the water's edge, the horizon where sky and lake blend, and the line between certainty and uncertainty blurs. The Great Lakes, symbols of stability and abundance for generations, are now understood as part of a restless, dynamic system. What seemed unchanging, the continental foundations, the perennial cycles, the calm of the deep, is now revealed as mutable, ever-shifting, ancient, and new. Each winter thaw, every violent storm, every subtle earthquake becomes a footnote in a story still in progress, a story that, after centuries, is still resisting closure. Should we fear what's been discovered, or should we marvel at the complexity and resilience of the earth beneath us? Perhaps the answer lies in vigilance, humility before the vastness of geologic time, and a determination to listen, measure, and prepare for the unpredictable. For if the Great Lakes conceal processes and histories only now coming to light, if the living rock is thinning, dissolving, quietly rewriting the story of a continent, our responsibility is clear. We must pay attention, not only out of curiosity, but out of duty. Who will be first to recognize new changes, to notice a pattern in the data, or hear the faint prelude to transformation? What future stories of resilience or adaptation, loss or renewal will the lakes demand those around them to tell? If the new science beneath the Great Lakes unsettles even the sturdiest minds, it is because its lesson is stark. Beneath every familiar landscape, the earth turns over, never truly still, never finished. So if you want to follow the latest in this unfolding story, where geology, mystery, and our shared future cross paths, remember to stay curious. Whether the Great Lakes are remnants of ancient glaciers or inheritors of deeper, fiery forces, the ground beneath them is alive with history and with change. As you stand by their shores, watching wind trace ripples across Erie or Huron, remember, sometimes the most astonishing stories are those hidden below your feet. Prepare, observe, and never confuse quiet with safety. For in the Great Lakes, as throughout the earth, the next chapter is always about to begin.